Well, good evening. Welcome to Georgetown School of Continuing Studies. My name is Wilson Felder, as Beverly indicated. I'm on the faculty at the Stevens Institute of Technology. I joined Stevens in 2013 after retiring from the Federal Aviation Administration, where I ran the National Laboratory for Research, Development, Test, and Evaluation of Aviation Systems. And I now run the Stevens office here in Washington, D.C., and serve as the Stevens liaison to the Master's in Professional Studies program with Georgetown. I'm joined to my left by Dr. Ramy Guirguis, who is the Senior Technical Advisor for USAID. He's managed the development, implementation, and integration of multiple large-scale enterprise applications, including the modernization of the Pension Benefit Guarantee Corporation's legacy premium accounting system. Please welcome Ramy Guirguis. Next to Ramy is Adam Firestone. Mr. Firestone is Senior Vice President and General Manager for Kaspersky Lab Government Security Solutions Incorporated. He has more than 20 years of experience designing and using military intelligence, security, and national senior leadership decision support systems. Please welcome Adam Firestone. Ms. Alice Quinn is Director of Programs at Northrop Grumman Corporation. She has successfully managed service development and integration programs under the demanding development and integration under the demanding conditions we all face, tight schedules, limited resources, and so on. She currently directs Northrop Grumman's programs with the U.S. Postal Service. Welcome, Alice. And last but certainly not least, Stevens alumnus, Dr. Robert Pitsko, currently serves as Technical Manager and Senior Technical Staff for Mission Command with the Mitre Corporation based out of Aberdeen Proving Ground. His professional and research activities emphasize systems engineering design with a focus on conceptual design evaluation, adaptability, complex system design, and system architecture, and system of systems engineering. Welcome, Robert. So we're each going to share a little quip with you. It'll take us maybe 25 minutes to do that, and then we want to really engage in conversation with you about some very important problems that we all face as practitioners, both practicing managers and executives and practicing system engineers. And I think it's fair to say everybody on this panel wears both of those hats. And so that brings some very interesting stuff. You know, I want to go back to the middle of the last century, right after the great cataclysm of the Industrial Revolution had worked itself out, but before the first glimmers of the information revolution that we now are in had begun to dawn. And I want to be reminded of a young man writing a freshman composition final exam at the University of Virginia in the fall of 1964. In those days, there were no computers, of course, because the information revolution hadn't started yet. So exams were written in blue books, you know, 8.5 by 5.5. Don't faint, Beverly. 8.5 by 5.5 lined booklets that you filled out with a number 2 pencil. And like all freshman composition exams, including the ones that are given today with laptops, this one involved the reading of several passages and then a set of 5 questions about those passages that you had to write an essay to answer. And so this young man diligently read all the questions, read all the passages, and then launched in linearly with question number 1, intending to finish question number 5 at the end of the 3-hour exam. Well, in the middle of question number 3, this young man realized that all the 5 questions represented different lenses through which the same larger question about the passages could be answered. And that the answer you would get by looking at that holistic question that cut across all 5 were much richer than the answer you would give if you were focused directly on each individual question. The only problem was, in order to do that job right, you would have to reorder the questions. 5, 1, 2, 4, 3. What to do? Halfway through the exam, questions 4 and 5 were still to be answered. and a lot of connective tissue had to be written. There wasn't time to ask for a new blue book and start over, so this fellow took the blue book, pried open the staples and removed them, resorted the pages, flipping one page so that pages 2 and 3 became pages 7 and 8. That reversed the order of the paragraphs that he'd written on those pages, but it turned out that that worked out. Put the pages back together in the new order, carefully slipped the staples back through the book, crimping them shut with the aid of the eraser on the end of his number 2 pencil. Wrote an introductory paragraph that explained what he had done, filled out the whole book, filling every bit of space, and having the text flow seamlessly from page to page, 1 through 10. That took a little bit of composition skill to do. And just as the 3-hour period was over, he turned the booklet back in, wrote his name on the cover and the obligatory honor code statement, and waited. 2 weeks later, the book came back. There was not a single red mark in that book. No misplaced commas or colons, no misspellings, no comments on style or phraseology, not even helpful comments on pacing and storyline, and so on. Completely blank. However, on the cover of the book, the instructor had written the grade, A+. And under that, one sentence, quote, "I am not competent to grade this exam," unquote. Full stop, end of story. Now, you may think that I'm telling you a story about Ernest Hemingway's freshman composition exam or William Faulkner's. No, this young man did not go on to see his work at the top of the bestseller list of the New York Times. He was not a great author. But what this kid was, by serendipity or whatever else, was a great systems thinker. Because systems thinkers think about the whole and not the parts. Up and out, not down and in. They are passionate about connectivity between one stovepipe and another, question 1 and question 5. And they worry about how the parts fit together to make a whole that's greater than those parts, and how information flows from one part to the other. My panelists tonight are that young man, although they're all way too young to have been in freshman class in 1964. However, what we hope to do over the next 20, 25 minutes is share with you some vignettes about how we live through these kinds of stresses and considerations in our everyday work. And I want to start with Ramy. Take her away.
Thank you, Wilson. I think this is my favorite topic to talk about because this is something that I live every day at work. One of the main challenges that we are seeing more and more, that a lot of the system development project, when they are just focusing on the technical and the system development side, it suffers a lot during the implementation. One thing that we're always advising the different clients and countries that you need to consider all of the holistic approach about it. You need to consider the policy, you need to consider the change management, the finance, sustainability, how if there is really business case for this project, what is the return on investment. And many projects suffer even if they have a very elegant and excellent technical perspective because they're not considering the holistic view of it. And strange enough, I found myself like, even I'm coming from system engineering background, I would promote system engineering everywhere, but I found more and more, through my work, we're advising a lot of countries in developing their national level IT systems. We are holding them back. You cannot just go and jump in terms of development without considering the whole holistic view. More and more, even if you noticed in the last several years, before you find project focusing on developing system, now you find a lot of projects starting when there is RFP, they start to include a component of policy development, a component of change management, a component of finance. So before we used to work in a project where everyone around us is engineer. This is not anymore. Each team, you'll find the policy people, you'll find communication, you find the HR people, you find the complete combination, not just the technical. So I think the dynamics here has been changing a lot across the years, and this is why I think this point is very, very interesting, and we live it in every day. So,
Thank you.
I can elaborate more through questions, but
we'll have a chance to answer questions later.
Sure.
Adam, what's your take on this?
Yeah, systems engineering, huh? So these guys are really smart, and I'm just me. So let me start by saying once upon a time I was a kid in Brooklyn, and I read every book I could find on airplanes. Loved airplanes. Wearing an airplane tie. And I learned about this thing called the strategic triad. Anybody remember the strategic triad? Come on, raise your hands. Any old Cold Warriors out there? Yeah, shout out to the Cold Warriors. So, strategic triad, manned bombers, submarines, land-based ballistic missiles. This was going to keep us safe, and I guess it worked, right? We're still here. So I spent about entirely too many years to name being a systems engineer, building complex systems. And I also had the opportunity to teach systems engineering in a major Beltway area integrator's internal university. And I met a lot of people, smart people, really, really smart people. But what we've done, as I realized as I taught these classes, was we created siloed people. We created people who thought, I'm a great developer. I don't need to be anything else. I'm an analyst. I don't need to be anything else. And there are people who have skill sets like that that I want to hire, but that's not who I hired in this current job. I hired systems engineers. And why did I do that? Because like the strategic triad, the systems engineer is a project success triad. 3 things. Number 1, domain. You got to know and be conversant with the domain you're working in. But if that's all you are, then all you are is a button presser. And I can find button pressers anywhere. Number 2, technical. How does the domain work? I don't need you to be God's gift to technology. I need you to be curious and find a way to understand how that all works. Number 3, process. How do I apply those things to achieving the process and the projects and the products that I want to achieve? The people with these qualities and the programs that produce people with these qualities in relative useful measure to each other are probably the single best bulwark against failure for any system you want to build or have built. And that's who I hire. That's who I'm looking for. And I'm not alone. So that's my little story about the Cold War and vignettes and airplanes. And if you want to talk airplanes after this, I'd be happy to talk airplanes.
We can probably talk some airplane trash.
I would like that. Thank you.
Alice, your turn.
Well, it's interesting because Dr. Firestone and I just met, and I brought a few notes, and they basically said about the exact same thing that he did. We at Northrop Grumman, we run a lot of programs, and in order to have successful programs that really deliver performance, affordability, and what I'll call the social and environmental responsibility that we see really requires holistic and a synergistic understanding of what the requirements are, what the resources, and a commitment, this shared understanding among the stakeholders of what are the goals, what are the requirements, and what are the resources, and the commitment of resources to see programs through. There's the need for the deep understanding of the technology, but it's the common understanding among all of the stakeholders. So one of the challenges that I see often is that different stakeholders understand their piece of the equation, and they understand it very well. But as they communicate it to other stakeholders, it's sort of like, okay, acoustic signal received. I heard you talking, but we're talking past each other. And to me, systems engineering management is all about really achieving that common understanding up front and through the entire life cycle process of the system. So, you know, that's my interest, and I think that the program between Georgetown and Stevens is excellent, an excellent way to achieve that. Because if you don't understand the policy and the policymakers and the executive leadership and the executive customers are not thinking about things and discussing things the same way that the engineers and the financiers are, you're gonna have problems. And so this is real, this is important stuff, so.
Thank you. Robert, take it away.
Well, I agree with what my colleagues have said on the panel. It's very important. I work for the Mitre Corporation, which manages several FFRDCs, federally funded research development corporations, not-for-profit entities that work in domains, the VA, the FAA, the DoD specifically. So I'm quoting from and that's where I support in the DoD domain. So just this week, the GAO released a report and some testimony that said this: weapons acquisition is a complex system, complete with incentives to pursue programs that are not always feasible or affordable. Weapon system programs often begin with validated requirements that have not been informed by solid systems engineering practices and do often not represent true needs as much as desires, have optimistic cost and schedule estimates, and are all too often unachievable. So in Mitre, working across all those FFRDCs, we've noticed that there's something needed beyond the hardcore technical aspects that we've focused engineering systems, engineering discipline, and learned on. There's something more than just that toolkit. And what we're searching to do across the corporation is get to a competency model that incorporates the softer skills. So what's exciting about this program here, when you look at the liberal arts, the humanities, the policy aspects from Georgetown, combined with the hardcore systems and technology from Stevens, where I'm an alum from, and teaching, it seems like the match made in heaven. The best parts of both sides of that equation. The hardcore science piece of it, that's very important and needed for engineered systems, as well as the complementary leadership, policy, communication. So leadership is something that you do to provide motivation and purpose. Management is something you do to organize, schedule, and deliver on time. What we find in these systems worlds where we're more and more interconnected and more software intensive, and we have specific understanding of parts of requirements and project managers who work in areas, it takes leadership across all of that to make them make decisions that might not be locally incentivized, but incentivized in a broader scale. So when you really look at what leadership needs to deliver and a curriculum for master's degrees, so if you're an engineer and you're very good at the solid piece and you want to do something more, you have to learn the soft skills and how to influence, and even when you're not in charge of other programs, to get that holistic effect. It's more than just the technology, and I think that's why this is an exciting program.
Outstanding. Let's go to the audience and see if anyone has a question for our panelists. All right, come on. Yeah, all right.
Do you feel in order
I need to have you use a mic because we're being broadcast.
do you feel to be an effective systems engineer that you have to have that deep technical experience, whether it's you're a mechanical engineer, electrical engineer, computer science? Do you feel that you need that base to be an effective systems engineer?
So I think I will take that on, and then we'll see if anybody has additional comments. I believe, and there's a lot of discussion in the community about this, but I believe in order to be a really effective system engineer, you need to have some kind of technical competence to start with. And so yes, mechanical engineering or mathematics or one of the physical sciences, and a certain amount of experience on the job, because at the moment, what we know about system engineering is mostly heuristics. We are building the theory, but we're a long way from having the kind of theory that we would teach to undergraduates. So that's part of the answer to your question. The other part of the answer, though, that I want to pound the table on is that we don't just need system engineers. It's very important for us to have trained engineers with some degree of system engineering background, but also these other qualities that all of my panelists have been talking about: the management skills, the leadership skills, the communication skills, and so on. So it's really a two-part answer. Any additional comments?
Yeah. I think more and more what I see, and of course it's depending on the position and the style of the project itself, but more and more what I see in life that people who are able to advance in their career and to shine in their position is really the one that have this technical and system engineering knowledge, but also are able to cross the gap in the other area. If you are just focusing completely in the system engineering side, it is great, but as I said, that the nature of the problem nowadays, it is they are more and more valued, the people who can cross this gap. And as mentioned before, we are having silos in education before, and the people who are able to cross these silos are the ones who really advance a lot in their career. And I see it every day. So.
And anybody else want to weigh in? Yeah.
So I think Ramy used a very important word, and he said knowledge. And I may be a minority here, but I'll go out on a limb. I think knowledge is more important than what degree you come to the table with. If you are able to acquire and process and apply knowledge, I will hire an attorney to be a systems engineer who has demonstrated that ability, who may have a political science degree. I don't need a computer scientist, but I might need somebody who can learn computer science and apply that triad that I spoke of earlier. And
so I think that's a really important point. This program is a program that is designed for somebody who has an undergraduate degree in economics, as you said, but who needs to have that system engineering component added to their toolkit. It is also a great program for an engineer who needs to have that management, leadership, and policy piece added to their portfolio. So as Ramy said, they can play both sides of that equation, which is so important. Can we take another question? Yes, ma'am.
No, it's just a follow-on question to this gentleman here is that if you were not, if you were not an engineer, you're looking now for a graduate kind of degree, I'm never going to be an engineer of any flavor. But so it sounds like you can still succeed as a systems engineer without being, a true engineer to start with, which hopefully is good news because Lord knows I'm not.
Okay, I'm going to take the first crack at that question too, and then we'll have some add-in. And I see Robert wants to join me. Absolutely, we are not going to make you into a system engineer, but we are going to give you the unvarnished material from our core system engineering courses that will allow you to understand what system engineers are saying, to understand the basic principles without being overwhelmed by the mathematics that's behind it. And let me just say that in our curriculum, one of the ways that you can see this playing out is if you were to come to Stevens to get a master's in engineering in systems, we would make you take the 4 core courses that are part of this program, and then we would make you take 1 or 2 quantitative electives. Those become a requirement of the Masters of Engineering program. But for the Masters of Professional Studies, you can take those quantitative courses if you like, and if you have the preparation for them. If you prefer not to, that's all right. It won't dilute the quality of your MPS degree, and it won't affect your understanding of system engineering principles. Robert?
So I agree with those comments. And I'll say that I teach one of those core courses at Stevens, the first one. And I tell the students that systems engineering is about communication. Communication in a written form, in an oral form, communication with interpersonal skills. And what we teach really is a process to understand the problem. We have methods, processes, and tools to really understand the domain, what the customer needs are. And then there's specific things you do to make it a profession and to do it routinely so that other people can understand and work with you. But as the systems engineer, you're generally working with experts in specific fields. It could be engineering or applied physics, depending on what you happen to be system engineering with. We talk about this V model of systems engineering, where on the top left of the V is understanding the need and the problem and the domain, and the top right of the V would be implementation and integration and testing and support. So systems engineering is a broad word, and if you're on the concept elaboration part working with NASA, it's very good to be space smart. So there is a proclivity to have that kind of domain knowledge in the very early parts of system definition and design. However, most systems engineering is interdisciplinary, and as we see, it's more and more about working with functionals that might not be directly related into your area of concern. So I would not be discouraged at all. A bachelor's degree is great, and the systems engineering process will expose you to the methods, processes, and tools, and also give you the opportunity to hook into some of that more technical material.
Okay, great.
Yeah.
Yeah.
Oh, well, I'll just a quick add-on, and I sort of remember Dr. Magna's chart with the circles and all of the jobs that you thought would benefit from this, and that's the way I think of systems engineering management and systems engineering leadership. It's not so much, you know, I don't necessarily disagree with Wilson that having, you know, some kind of technical background helps, but if leadership is what you're looking for, then this systems engineering management program, I think, would be very effective for that.
Right. Did I have a question up front here? You were not raising your hand. Anyone else? Yes, sir, over here.
I think it's more of a comment than necessarily a question, but would it be fair to say, you know, I've heard you mention aviation quite a bit here already this evening. And yeah, I've often thought about writing a book. Everything I needed to learn about business, I learned in flight school. And an aircraft is an advanced, complex, adaptive, complex system. You know, so while in flight school, I'm not an A&P mechanic, but I do understand the mechanics of the engines. I don't build propellers, but I understand their function on the engine and how it applies to the entire system. So what it seems like we're talking about, and also failure to properly manage resources can be catastrophic. So what it sounds like we're talking about here is learn to be a pilot. How do I make these systems work synchronously and in harmony to get us from one place to another? Would that be a fair assessment?
I would agree with the last part of your comments, yeah. Any other thoughts?
So we live in this world of silos. We train people to be silos. Heck, in the same program, we don't talk to one another because we don't have the same job title. That's catastrophic. The solution, and this is based on 20+ years of doing this, is to be the bridge. And the systems engineer is the bridge. The systems engineer manager makes the bridge happen. And what we're talking about with respect to this program is really the methodology to become that bridge. You know, it's a linchpin, it's a hinge, it's the single most important thing you can be. Because if you don't bring all those disciplines together, it's 5,000 monkeys typing on a typewriter, and eventually someone writes King Lear, but you were hoping for Nancy Drew. You know?
So that's really great, Adam, because you made the point that the system engineer is the bridge and the system engineering manager makes the bridge happen. That's a very clear way to distinguish this program from other programs that address other aspects of the overall system engineering problem. Ramy, did you have a comment?
Yeah, and I think this is the point, focusing on the management part, system engineering management. I think this is the key here, because to make this bridge happen, you really need to have the knowledge in all of this area to be able to make it work out. You don't need to be an expert in all of the area, but you need to have a knowledge in all of this area. So and I think this is the management piece here, is system engineering management piece is the key component. So.
Next question. We have time for one more question. We have time for one more question. Absolutely. One more questioner. You said we have time for one more questioner.
Say them fast.
I would like a response to this statement. The art of systems engineering is distilling its complexity.
Well, that is the first question is you would like a response to that. Anybody want to respond?
Absolutely.
Go for it.
Absolutely. I mean, that is the whole idea of making sure that all of the different stakeholders are speaking the same language and comprehending and working towards that common goal. I mean, systems are not built today by a single person. Systems are, I mean, we're in an international world, right? So it is absolutely that distillation, and that is so important.
The follow-up. You still have the microphone?
No,
they took it away. You said you had 2 questions.
Scalability, right? If we define scalability as a system being able to expand and contract.
And
What's
I
the
missed the
question?
question. I'm sorry.
Response to it. All right, if we define scalability as a system being able to expand and contract.
Is that a correct definition? Is that what you're asking?
Feedback.
Okay, go for it.
Somehow I think it's correct, and this is where one of the common issue that we find some people make a prototype for a small system, and then all of a sudden it was successful and said, okay, now we can deploy it in thousands of locations for thousands of users, and it will be a complete failure. And this is where we're telling them, for scalability, you need to start bringing back to the system engineering principle. It is not a toy anymore. It is not prototype anymore. So definitely scalability is taking whatever you build and try to implement it to large scale. And this is where the value of system engineering become very critical. So.
Looks like you want to add in.
So it's a wonderful way to think about scalability. Scalability, of course, being more of something or less of something of the same thing. Systems engineering, broad term, many kinds of systems, many classes of systems. Something with a whole of a little bit of parts. It's a product, the iPhone, many, many iPhones, the software that makes the iPhone work. So scalability means different things depending on which class of systems we're in. When we say complex systems, we're talking about a class of systems that have social technical interactions that are hard to predict and could have a drastic outcome on the performance of the system. Scalability in that range is really the frontier we're researching to understand how to completely and routinely distill that into practice, like you mentioned in your first comment. So scalability means things at different classes of systems, and in the complex systems world, we are still working for ways to measure that and routinely employ it.
Okay, so I'm being told that we are running out of time here. I'd like you all to join me in thanking the panel. Again, Ramy Guirguis from USAID, Adam Firestone from SAIC, no, wrong. From Kaspersky Lab Government Solutions. I'll get it eventually. Alice Quinn from Northrop Grumman, and Robert Pitsko from Mitre. Thank you very much to all of our panelists, and thank you for joining us.